Hi students, welcome to Chemistry Online. In second year, in previous class we discussed about extraction of iron from iron ore. In this class, we are going to discuss extraction of copper from copper ore. Extraction of copper we are going to discuss. So, how copper is extracted in this class we are going to discuss. So, first of all, you know ore which is suitable for extracting copper. Here you have to know ore. So, ore is copper pyrites. Copper pyrites is the ore. Its formula is composition. Composition is CuFeS2. CuFeS2 or Cu2S Fe2S3. Cu2S or Fe2S3, it is the formula. It containing sulfide ore. So, first concentration of the ore we have to done. So, concentration of the ore. Concentration of ore. How concentration of the ore means it contains sulfide ore. So, sulfide ore is concentrated by froth flotation method. Sulfide ore is concentrated by froth flotation method. Froth flotation method already we discussed. Next, reduction. Next, concentration of the ore. After that, see roasting. Next, roasting we have to do. Roasting means heating the ore in presence of oxygen at a high temperature is called roasting. If you roast CuFeS2 or Cu2S into Fe2S3, if you roast in presence of oxygen, then the sulfide ore can be converted into Cu2O, Cu2S plus Fes plus SO2 will be forms. So, here Cu2S, then Fes3, 3 plus 1 4, if you take 2S, here Fe2S3 is there, then how many oxygens? So, here 2 oxygens, SO2, it is balanced. So, on roasting Cu, it is copper pyrites and roasting, it is copper sulfide, ferrous sulfide and sulfur dioxide. Again, copper sulfide is heated in presence of oxygen, then it can be converted into oxide Cu2O plus SO2. So, here Cu2, if you take 3, if you take 2, 2 to the 4, if you take 2, if you take 2, then it is balanced. Copper sulfide can be converted into copper oxide. So, here and then again Fes I am taking Fes, again heating with oxygen in presence of oxygen, it can be converted into FeO plus SO2. For balancing you have to write here, then what? If you take 2, 2Fe, 2Fe. 2S means you have to take 2, 2 to the 4 plus 2 6, then here you have to take 3. So this is the way roasting means copper pyrites can be converted into copper sulfides. Copper sulfide can be converted into copper oxide. It is roasting. Roasting means heating the ore in presence of oxygen. Next smelting can be done. Next smelting. Here smelting can be done. Smelting. Smelting means so here FeS can be converted into FeS plus O2 gives rise to so FeO plus SO2. If you take 2 FeS 3 O2 then 2 FeO plus 2 SO2 can be forms. Smelting means adding coke. So to the cup Cu2S adding coke and heating in blast furnace, that is called smelting. Then here FeO reacts with SiO2 which is impurity, then it forms a slag FeSiO3, it is a slag. It is a slag. Then again see here Cu2O plus FeS. Here Cu2O plus FeS reacts with each other. Cu2O plus FeS gives rise to, then what happened? Cu2S plus FeO is formed. Here the mixture of Cu2S plus FeS less amounts is called matte. So here the mixture of Cu2S plus FeS small amounts, FeS small amounts is called matte. Is called matte. See, this is a very important note. So next we have to do besimerization. Then what happened means Cu2S plus Cu2O on heating. Cu2S plus Cu2O on heating very high temperature. Cu2O plus Cu2S heating nearly 1170 kelvins temperature. So here 6 Cu is formed plus SO2 gas is escapes. Okay, 6 Cu means here you have to take 2 to the 4 plus 2 6 Cu and SO2 gas will be escapes. Here you have to know when solidification of copper, here molten see the mixture of Cu2S plus FeS is called molten copper. So molten copper is nothing but a matte. The molten copper can be converted into solid. At the same time here SO2 gas leaves blisters on the surface of the copper gas. Means yes, on the surface of the copper on the surface of the copper, when SO2 gas is leaving from copper, it leaves a small air bubbles. They are nothing but blisters. So it is nothing but a blister copper. So it is called blister copper. Blister copper. Why it is called blister copper means when SO2 gas leaves copper, it forms when SO2 gas escapes from Cu, it leaves blisters on copper, surface of the copper, on copper. So it is nothing but on copper. So it is nothing but a blister copper, which is 98% pure, which is 98% pure. So this is 98% pure. It is a blister copper. So blister copper can be purified by refining. Blister copper can be purified by refining. Refining means again purifying or a refining or a purification. So any metal which is purified after all these methods which contain some impurities, the metal again purified by electrolytic process, and means by passing electricity removing of impurities is called electrolytic process of purification. That is nothing but refining. Refining means which is a pure metal is obtained after refining, where is 100% pure. So here refining, electrolytic refining we have to do. In the electrolytic refining 99%, first we have to do polling. So on polling 99.5% copper, 99.5% copper is obtained. Okay, 99.5% copper is obtained. Polling means we are going to discuss in the next class, which is molten copper is mixed with green wood poles, then small impurities which is escapes in the form of gases is called polling. That is we are going to discuss in the next class. Here on polling 99.5% copper is obtained. Next electrolytic refining. So this is refining. First one is polling. Next electrolytic refining. Electrolytic refining means taking copper, impure copper, which is act as anode, and pure copper can be act as a cathode. So taking electrolytic solution and passing electricity, then impurities can be deposited at anode. Impurities are deposited at anode, and copper can be purified, which is 100% pure copper. 100% pure copper is obtained by this method. Okay, so this is the way extraction of copper can be done. So here it is extraction of copper, which is we are taking ore, copper pyrites, composition is CuFeS2 or Cu2S Fe2S3, then concentration of the ore. So copper containing sulfur as impurity means it is a sulfide ore, so that is concentrated by froth flotation method. And then roasting, so heating the iron pyrites in the presence of high temperature in the blast furnace is called roasting. So if the ore is not oxide, you have to convert it into oxide. For converting oxide, we have to use roasting or calcination. Here roasting can be used. It is done in blast furnace. So Cu2S can be converted into Cu2O, and FeS can be converted into FeO. Then smelting. So here flux we have to add to this, then we have to convert FeS into FeO. So FeO reacts with SiO2 which is present in the impurity, so which forms a slag. Here a mixture of small amounts of FeS and Cu2S is called MATI. So the MATI is on isomerization, so that is nothing but solidification of copper can be done when liquid copper can be converted into solid. So that is nothing but a solidification of carbon. In the solidification of carbon, SO2 gas is escapes from the copper, which forms a blister. That is nothing but a blister copper. Blister copper is 98% pure. Then which is done by refining or purification, refining or purification, refining or purification. Then here first pooling we have to do. So molten copper is taken into a bone vessel, bone ash vessel. The vessel is made with bone ash. So that is mixed with green wood poles. So on mixing the molten copper with green wood poles, so small impurities they are escaping in the form of gases. Next we have to do electrolytic refining. In electrolytic refining, impure copper can be act as anode and pure copper can be act as a cathode, and suitable electrolytic solution electrolyte we have to take and forming electricity. So finally 100% pure copper is obtained in this process. Next, extraction of zinc we have to discuss. Next, extraction of zinc. Okay, zinc is extracted from zinc blende. Ore we have to know first. Zinc is extracted from ore is zinc blend. Zinc blend composition is ZnS. It containing sulfide as impurity. So concentration of the ore, it is a ore, it is a composition, it is a concentration of ore, concentration of the ore by froth flotation method, by froth flotation method, the by froth flotation method. Okay, so why? So we have to concentrate it by froth flotation method because it contains sulfide as a impurity. And then roasting we have to do. Then roasting. Then roasting. So roasting means ZnS is heated with oxygen, then it can be converted into ZnO plus SO2. So you have to balance 2 ZnS, 2 SO2, 2 ZnO and 3 O2. 2 zinc, 2 zincs, 3 2s are 6, 2 plus 2 2s are 4, 2s and 2s. It is a balance. So here small amounts of ZnS reacts with O2, that can be converted into ZnSO4. ZnS reacts with O2, then it can be converted into ZnSO4. If you take 2 oxygens, then it will be ZnSO4, zinc sulfate is formed. ZnSO4 it decomposes into ZnSO4, which it decomposes into ZnO plus SO2 plus O2. Okay, ZnO. So how many you have to take? 2. 2 4s are 8. Then if you take 2, if you take 2, then 2 Zn, 2 Zn. 2 sulfurs means you have to take 2 sulfurs. Okay, then 2 sulfurs, then 2 4s are 8, then 2 2s are 4 plus 4 plus 2 6, 6 plus 2 8. It is a balance. So in roasting, ZnSO4 can be converts into ZnO and SO2. Okay, so after roasting, it can be reducing. You have to add reducing agent, then ZnO can be reduced into Zn. Okay, then here we have to do reduction. So here ZnO on adding C, then it can be converted into Zn plus CO, which escapes. Here C can be act as a reducing agent. If you add ZnO plus CO and then also Zn plus CO2, gas can be escapes. So here it is a extraction of zinc from zinc blend A. First froth flotation, so that is nothing but a concentration of the ore, next roasting, next reduction, and then purification can be done, refining can be done. It is nothing but a purification of zinc, purification of zinc. Then it is extraction of copper. So it is extraction of copper, it is extraction of zinc. So this is briefly today's topic. So what I mean to say here, so extraction of copper from its ore and extraction of zinc from its ore. So in this stage, first ore we have to take, that is nothing but a copper pyrites. Its composition is a CuFeS2 or Cu2S Fe2S3. So 2Cu, so 2Fe, then 4, then 2-2-2-2-2, then it is a simplification form. Then concentration of the ore same, froth flotation method, here also froth flotation method. Why we are using for concentrating the ore froth flotation means here ZnS means sulfide as impurity, it is sulfide ore. Here also copper pyrites means which is the sulfide ore. So we have to remove iron and sulfur, means by froth flotation is the best method to remove sulfide ore. Then roasting, so heating the ore in the presence of oxygen at a high temperature in the blast furnace, it can be done. Then it can be converted into oxide Cu2O and FeO, ferrous oxide, cuprous oxide. Then here smelting can be done in the blast furnace by adding reducing agents like coke. Then it can be removed, it forms a slag FeSiO3, which is impurity. So ferrous is removed in the form of FeSiO3. Then here a small mixture of Cu2S plus Fes. Here it is Cu2S plus Fes, which is remains in the blast furnace, that is called MATI. So MATI means, so the on taking MATI into the Bessemerization, Bessemer converter, so which is used for Bessemerization, so which is lined with Bessemer. So here Cu2O plus Cu2S gives rise to 6Cu. Copper, solidification of copper can be done here. Solidification of copper. Solidification of copper can be done here. So when solidification of copper, SO2 gas escapes from the surface of the copper, which forms blisters, that is called blister copper. So when SO2 gas escapes from the copper, it leaves gaps, it leaves blisters on the copper, so which is 98% pure. After that refining or purification we have to do. So first pooling, 99.5% copper is obtained. Next electrolytic refining. Electrolytic refining means by using electricity purification of the metal, again purification of the metal, it is the final stage. After this electrolytic refining, any metal have to get 100% pure, then it is also ore. So after reduction, zinc also we may use for refining, which is nothing but a distillation or a liquefaction we have to use for zinc. Okay, so this is briefly about copper, extraction of copper from copper pyrites, extraction of zinc from zinc blend. So iron already we discussed in previous class. So I drawn a diagram which is a blast furnace, that is extraction of iron, this is extraction of copper, this is extraction of zinc. In next class we are going to discuss extraction of aluminum. So 4 metals extraction is over, that is given in our chapter, present chapter, which is nothing but a metallurgy. So it's a time to leave.